Hello everyone, welcome back to the channel, and in this video we will be building an expert cooking helper chatbot. And via this hands-on exercise we will try to learn concepts that are related to AI engineering, and we will understand how the enterprise AI works, and we will learn stuff related to that. So without any further ado, let's get started. And this will be a hands-on based series, so we will code this chatbot live together so that we get and we learn via hands-on approach. So let's get started, and before we get started with the code, let me explain few important concepts that will help us later. So first thing is, whenever a user provides any prompt to an LLM, for example ChatGPT or any other, let's say in our context I ask, how do I make my grandmother's butter paneer? Okay, so in this case the LLM might be having information about recipes on butter paneer, and but the problem is that the LLM will not know how my grandmother used to make butter paneer, right? And if it does not know the exact answer, or it does not have the exact data, what the LLM tends to do is it tends to hallucinate. Basically, it will make up things on its own, and that becomes a problem for us. Another problem that we see is the LLM might provide some totally wrong information as well. Okay, and this wrong information it provides us confidently, and like it creates a scenario of misinformation. And also it can give us some generic information or some generic recipe of any paneer recipe that it finds across its data source. So to prevent all these things, we implement something called RAG. Okay, RAG is basically retrieval augmented generation. Okay, so if you understand it in literal terms, basically what we are doing here is we are retrieving or bringing in relevant data, and we are augmenting or enriching the LLM with this relevant data or the extra new data, and based on the combination of these two things, we are generating the answer to our questions. Correct? So let's say how the traditional LLM would work is, we give the user gives a question. The question would directly be passed to the LLM, and based on its training data, the LLM might provide right or wrong answers. Correct? With the incoming of RAG, what would happen is, whenever a user gives us a question, what we will do is we will find relevant data or docs for this question. We will find relevant. So mark the keyword relevant here, because this becomes important later. So we find relevant data or docs, and then this relevant data or docs is passed on to the LLM. Okay, so this is the LLM. We pass on the user's query, and we pass whatever docs we fetched, whatever new data we fetched here, right? So we pass in. So now we have augmented the query with the extra or the new data, so that the LLM has more information about what to generate. Okay, and when the LLM acts on this data, the LLM provides us correct answer. Okay, so this is basically what we are going to do in this exercise. And you see the word here I told about relevant. Okay, so this introduces us to a different way of searching. So generally, how do we search? Generally we do keyword based searching. Correct? So in traditional search, let's say we are searching for butter paneer, so only the exact words will be matched. Correct? Maybe all the recipes containing butter and paneer will be fetched. Okay, and let's say someone searches for paneer makhani meaning and only doing keyword search, the paneer makhani would be missed. The recipes or the data related to paneer makhani would be missed, and that would not be good for us. So that's why, to solve this problem, something called vector search was introduced. Now what is vector search? Vector search is also called semantic search, and what this does is it searches on the basis of meanings of the phrases or words. So how this is done is, let's say you input a search term butter paneer. What will happen is the text butter paneer will be converted to numbers, some numbers, okay, or vectors. So I'm not going into much detail now, but what would happen on a very high level is the butter would have a value of, let's say, 0.7, and the paneer would have a value of, let's say 0.2. Okay, So all the search terms would be converted to vector embeddings. These are called vector embeddings. Similarly, whenever someone enters the term paneer makhni, this is also converted to its corresponding vector embedding. So this will be 0.21 and maybe makhni will be 0.78, something like this. So how this vector search would work is, it would bring in all the documents whose vector embedding values are nearby. So butter and makhni, it will see that, hey, but makhni is 0.78, butter is 0.7, and paneer is 0.21, and here also paneer is 0.2. So both these documents would be fetched, or both these results would be fetched as search results. So the end result of this will be, we are finding meanings and not just words. So in this way, vector search provides us with all the relevant documents, correct? All the relevant documents that we need to provide extra data to our LLM, and that in turn provides us with a correct answer to the prompt. So while building our expert cooking helper chatbot, we will see these concepts being used. Another example to explain how vector embedding works would be, let's say we have some prompt saying how to cook pasta, and let's say we have another prompt saying pasta cooking instructions. Let's say we have another prompt saying car repair guide. So how this would work here is, this prompt, right, the vector embeddings would be assigned like this. For example, how this word, let's say, I'm just assuming here this would have a vector embedding of 0.2. So vector embedding values lie from 0 to 1, 0 meaning least match, okay, basically it doesn't match, and 1 meaning exact match. And all the LLM service providers have implementation of their vector embeddings. So let's say how is assigned 0.2, and 2 is 0.8, and let's say cook is 0.1, and so on. Similarly, pasta cooking instructions, when this is converted to its vector embedding, so let's say pasta is assigned a value of 0.21, and cooking is assigned a value of 0.79, and instructions assigned a value of 0.11, and so on. Okay, so all these are not random values. These are assigned using something called cosine formula for calculating these values and generating likenesses between various terms. So we can have a separate video on that, but now we'll not go into that depth. And coming to the third prompt, when the vector embedding for this will be created, this will be little different. So let's say car will have 0.9, and repair will have, let's say, 0.11, guide will have 0.3, and so on. Okay, so when the vector search happens, these values, it will see that, hey, the value of the vector array, right, 0.2 and 0.21, 0.8 and 79, 0.1 and 0.11, all these two are similar. But when it sees this one, it will see that it is 0.9, 0.1, and that is different. And this is how it brings out the vector embeddings, or the documents or search terms which have similar meanings. We'll start with the implementation in the next video, and see you again. Thank you.